What is a relational database management system? It's a collection of data points with predefined relationship between them. The relational model organizes data into tables, with each row representing an individual record in each column consisting of attributes that contain values. This tabular database structure makes it easy to establish relationship between data points so that the information can be accessed in a variety of different ways without reorganizing the data itself. You can join the tables in a relational database to gain deeper insight into the interconnection between diverse data points. For example, the table customer has columns name and address with row values John in California. Similarly, the table product has columns name and cost with row value shoes and $12. You join the customer table with the product table to identify the popular products that customers purchase more frequently. In a shared relational database is a way to store and access data with predefined relationship. A relational database management system, or RDBMS, is a software layer of a tools and services that manages relational tables. In practice, the terms RDBMS and relational database are considered to be synonyms. A relational database provides a consistent interface between applications, users, and relational database. Organizations use RDBMS for managing large amount of business critical information from various departments. Multiple users can work with the same database in different ways. For example, they can perform database operations and aggregate key data points without creating data redundancy. Relational database management system also give your database administrator greater access control over your data. A relational database stores and organizes data points that are related to one another. Based on the relational database model, a relational database presents datasets as a collection of tables and provides relational operators to manipulate the data in tabular form. So the second question is provide a diagram of relational database. So as you can see on the screen, here's the example of diagram of database. How do relational databases work? Relational databases work by providing an environment for which application access data and reassemble it in various ways without having to reorganize the data tables from within the application code. We give some key features of a relational database system below. So first is the data model. The relational database is made of tables that represent real-world objects or concepts, often referred to as entitles. Each column in a table holds a certain kinds of data known as an attribute. In field stores the actual value of an attribute. The rows and columns in the table represent a collection of related values of one object or entity. You can mark each row in a table with a unique identifier called the primary key. A foreign key references the primary key of another existing table and creates a logical connection. Rows among multiple tables thus relate together using a primary key foreign or key prepairing. For example, each row of an orders table can contain a foreign key that contains a customer ID, which identifies the rows in the customer table. That contains all the information about the customer. Second, the SQL, or Structured Query Language. The primary interface to communicate with relational databases, SQL became a standard of American National Standards Institute in 1986. All popular relational database engines support the standard ANSI SQL. You can use it to update, delete, or store data, retrieve data subsets, and manage all the aspects of your relational database. SQL is a fairly easy to learn as it uses common English keywords in its statement. It's also integrated well with different programming languages. For example, you can embed SQL queries with the Java programming language to build high-performing data processing application with major SQL database system. The third one is transaction. A relational database transaction is a one or more SQL statement that run as a sequence of operations form a single logical unit of work. Transaction provide an all or nothing proposition, meaning that the entire transaction must complete as a single unit if the relational database management system cannot complete any part of the transaction. None of the individual components go through In the relational model terminology, a transaction results in a commit or a rollback. The database management system treats every transaction coherently and reliably, independent and isolated from other transactions. The last one is the ACID compliance. All relational database transactions must be atomic, consistent, isolated, and durable, or also known as ACID compliant to ensure data integrity. First, the atomicity. Atomicity requires that the transaction as a whole should execute successfully. If a part of the transaction fails, then any changes that were made as part of the transaction are rolled back. Consistency. Consistency requires that the data written to the relational database as a part of the transaction must adhere to all defined rules and restrictions, including constraints, cascades, and triggers. The third one is isolation. Isolation requires that each transaction is independent unto itself. When multiple users attempt to modify data in a relational database simultaneously, concurrency control mechanisms prevent them from overwriting each other's changes. Last one is durability. Durability requires that all the changes made to the relational database be permanent once a transaction is successfully completed. Give two important aspects of relational database. The primary benefit of the relational data model is the ability to derive meaningful information from data. For example, you can count, sort, and group data in a table, as well as perform mathematical operations and generate complex reports. Hence, relational database systems remain the most popular for data storage today. We give some more benefits below. So here's the first important aspect. First is the data integrity. Data integrity is the overall completeness, accuracy, and consistency of data. Relational databases use a set of constraints to enforce data integrity in a database. These include primary key, foreign key, not null constraint, unique constraint, default constraint, and check constraint. This integrity constraint help enforce business rules on the data in the tables to ensure the accuracy and reliability of the data. In addition to this, most relational databases also allow custom code to be embedded in triggers that execute based on action on a data point in a database. Custom code can also be embedded in stored procedures that execute when they invoked by a client or application. Second is the security. Most relational database management systems have sophisticated access controls. Your database administrators can precisely determine who gets what access to which data. You can limit access to read, modify, and delete data even at the individual cell level. Such granular access control make relational database very secure.